So let's roll on to our next set of speakers. Very excited, as I am very excited to introduce all of our speakers, two absolute heavyweights, two titans in the DevOps and observability world, Andriana Villela and Margarita Medina. They're both developer advocates, a senior developer advocate and a staff developer advocate, respectively, at Lightstep. Adriana has got over 20 years of experience in technology, really just helping companies to focus on reliability excellence, right? By leveraging observability, SRE, DevOps practices, the author of blog posts, the co-host of the On Call Me Maybe podcast, CNCF ambassador. The list goes on and on. Anna, speaks on all things SRE, DevOps, reliability. Is also, on the podcast, co-host podcast for On Call Me Maybe. Self-taught engineer, many years of experience on the Kubernetes release team, and really works with the mental health community and bringing more Black and Latinx folks into tech. So if you have any questions, as always, over the course of the presentation, please feel free to ask them in the Slido. Otherwise, I am very pleased, very honored to pass the stage over to Adriana and Anna. Take it away.
Thanks so much. Well, hey, y'all. Welcome to Keeping Your Engineers Happy, the case for self-service tooling. We are super happy to have you join us here today. Now, before we get started, let me tell you a little bit about us. So my name is Andriana Villela, and I love solving hard problems, whether it's part of my day job as a senior developer advocate or on a rock wall, which is where you'll find me when I'm not at work. I am heavily involved in the open telemetry community as a co-lead of the OTel end user working group. I am a CNCF ambassador, second year HashiCorp ambassador, blogger, and host of the new Geeking Out podcast. And I'm very happy to be speaking here on this virtual stage for such a great cause.
My name is Margarita Medina. When you don't find me near computers, you're not going to find me near rocks like you'll find Adriana, but you can find me near makeup and making some Hispanic food. I am a staff developer advocate at Lightstep, and I'm also a CNCF ambassador. I've also done other community initiatives like being part of the AWS Community Builder Program, being part of the Kubernetes Code of Conduct Committee, and the Captain Governor's Committee for another CNCF project.
All right, so now that we've got the pleasantries out of the way, let us get started. So as we stand here before y'all, I cannot help but reflect on just how complex technology has gotten in the last couple of decades. Now, when I graduated from university in 2001, which honestly doesn't feel like that long ago, but it was, having internet access on your mobile phone was barely a thing. And shout out to flip phones. If you remember those, I totally miss them. The Google search engine had been around for about 3 years, and we were just starting to go from those lovely 3.5-inch floppy disks to USB sticks for portable personal storage. Monolithic apps were a thing. Java was a hot language, and cloud, what cloud?
Oh man, to think back about those times. Definitely miss flip phones. It's nice to still see them making the rounds here and there. But you're right. The way that we work with software has been changing, and how we work with it actually depends very much on the size and the maturity of the organization. We've seen a lot of this movement happen across the last 20 years, but one of the most recent incarnations of this conversation is with the platform engineering movement. When we look back, when the DevOps movement started, we were actually focusing on trying to work together and collaborate, break those silos. At that time, maybe we didn't have as many customers to worry about, or maybe we just didn't realize that they were as important. As software continued to eat up the world, we saw that SRE actually ended up gaining a ton of momentum. SRE builds on top of those DevOps principles, but it also brings together the customer impact and reliability into the bigger picture. As companies gained a lot more customers, they had to manage a lot more complexity within their infrastructure, their tech stack, more services, and they brought in more site reliability engineers. More businesses relied on money coming just from online experiences, and reliability started becoming a high priority. Of course, we can take a look at the pandemic also creating a bigger spike in that. So now with platform engineering, we need to remember that how site reliability engineering made the customer experience better and more reliable, platform engineering is making the experience for the internal customer, like a developer, better and more reliable. But we also have to keep in mind that platform engineering is not developer experience. Platform engineering also takes other things into considerations, such as consistency, security, and reliability.
All right, folks. Now that you've got a little bit of background, from here on in, Anna and I will be playing different roles in order to illustrate things a little bit better and just to make things a little bit more fun, because we should always have fun while we work, right?
Yes, yes, yes. I am going to be taking the role of a developer for this next part.
And I will be playing the role of a platform engineer. So, in true fashion, in 3, 2, 1, action.
Action! As a developer, I've noticed that the way we build and we test and we deploy applications has gotten more and more complex. We have the public cloud, but within the public cloud, we run different things, such as Kubernetes, serverless workloads, and databases. Unfortunately, that means that as a developer, if I want to be able to have access to the tooling, I am at the mercy of another team. I'm at the mercy of the platform team. I hate waiting for my platform team to do things for me. I really want my autonomy.
Man, you think that it sucks for developers? I mean, what about us platform team members? Sure, sure. Platform teams have the so called keys to the cloud kingdom, but that's only part of our responsibilities. I mean, we also have to maintain these systems. So, between having to give developers access to things and maintaining reliable systems, we platform team members are super duper stressed out. Like, do you know how many Jira tickets we get on any given day? Way, way, way too many, and I'm honestly sick of them. I do cool things like creating new automations and improving overall system reliability. I mean, that's the fun stuff.
Um, but what about me? I mean, I'm hearing you complain about all these Euro tickets and all of this, but I'm also sick and tired of waiting for you to fulfill my requests so that I can get my work done. Sometimes I wait around for hours, if not days, for a request to be fulfilled, and I'm actually usually on a deadline. I'm used to doing things for myself, and y'all are literally tying my hands here. Clearly, things can't keep going on this way. You're frustrated because you're overworked, and I'm really frustrated because I'm always having to depend on your team for stuff. So we kind of have to come up with a solution here. What's it going to be?
Well, let me think for a second here. One of the main themes of platform engineering is to codify all the things, which we as a platform team are already doing. So, for example, when you ask us for a new namespace in your Kubernetes cluster or to create a new Redis instance, it's not like we do all this manual work to set things up. I mean, we've got scripts to create and configure all the things. And we actually already have tooling in place that helps us platform engineers do our jobs more efficiently, like Terraform, Argo CD, Captain, Crossplane, Tecton, just to name a few.
I mean, that sounds all great and all, but these actually are not really solving the problems that our organization is facing right now. Keep in mind that as an organization, we now have more users, we have all these services, but on top of it all, they're also asking us to release things a lot faster. What I want is a way to get the tools that I need, but when I need them. I really want a stable environment. I want my team in London and England to have the exact same environment that my team in Caracas, Venezuela has. I'm tired of wasting my time using tools that InfoSec hasn't approved of yet, whether they haven't gone through enough security audits or they're still not SOC 2 compliant. And I really don't want to be concerned around the underlying infrastructure of my systems. And I want the best practices to be followed for every single new project that is spun up. I need guardrails.
Okay, well, now you got my wheels spinning. So, with keeping that in mind, I guess it would make sense for us to take things one step further and codify how we deliver things to developers as well. I mean, we understand that it is very time consuming and automation would be very helpful for everyone involved, including our good friends in finance. Am I right?
Oh, you said finance. I think that team really needs some love from us. That's awesome. Because by codifying the delivery of these services, it means that I actually get access to the tools that I need when I want them. Whether it's 2 in the morning when I'm up and still trying to debug something, or it's just 2 p.m. in the middle of my workday. And in doing so, we now have the tooling that is available on demand when I want it, not when you're available. By codifying it, you also ensure that you don't get the work someone machine type of more tickets, making it both repeatable and reliable. And like I said, we're going to make InfoSec happy because y'all are going to be able to bake security into it. And finally, those financial folks are going to be really happy with us because we're not going to be wasting money on resources that we don't need. And we're also making the planet happy. We're going to be setting expiration dates for our development and our staging environments so that resources are not being wasted willy nilly. And that's going to save on money and it's going to help us save the earth because it lessens our carbon footprint.
Exactly. And the best part is, it turns out we don't have to reinvent the wheel because there are actually a number of self service provisioning tools out there on the market that can help us with just that. And these tools, I've done some looking around, include but are not limited to Crossplane, Backstage, Cradix, and Port. And I do want to point out that both Crossplane and Backstage are part of the Cloud Native Computing Foundation, or CNCF, which is a body under the Linux Foundation that oversees a number of open source projects, including Kubernetes, which we all know and love.
By any chance, you have a demo available of this thing that you're talking about?
Well, you're in luck because as we were talking, I magically whipped up a little something to show you because, I'm that good. It's very cool and it runs on Kubernetes. But first, we do need to take a little detour and talk about OpenTelemetry, which, by the way, is another project under the CNCF. Now, OpenTelemetry, or OTEL for short, is an open source, vendor neutral framework for instrumenting, generating, collecting, and exporting telemetry data. And the great thing about OpenTelemetry that I absolutely love is that it has a backing of all the major observability vendors, making it the standard for instrumenting your applications. So OpenTelemetry is here to stick around. But we can't talk about OpenTelemetry without talking about a component of OpenTelemetry called the OTEL collector. Now, the collector is a vendor-neutral service used to ingest, transform, and export data to one or more observability backends, i.e. tool that's going to render the data and you can do stuff with. So the collector consists of three main components. We have a receiver, receivers that ingest data, whether it's from your application code or your infrastructure. We've got processors, which are things that transform your data. So a processor can do things like mask data, which we all love to make sure that we're masking PII data, adding attributes, removing attributes, filtering data, etc. And then we have exporters, and these convert your data into a format that's compatible with your chosen observability backend. Now, you can think of the OTEL collector as a data pipeline. And the collector itself can be deployed to Kubernetes. And one of the ways to do so is with the OTel operator. The OTel operator is used to manage the deployment of the OTel collector in Kubernetes, but it also does a bunch of other cool things, and I could tell you about that another time. I could go on and on. But an operator, as you may or may not know, is a software extension to Kubernetes, which makes use of custom resources, using everyone's favorite, YAML, to manage applications and their components.
Why is this something that I care about in terms of the project that we're doing?
Well, because we're going to use Cradix, which is one of the tools that I mentioned earlier, to make the OTel operator available for developers so that they can deploy the OTel collector on demand to their Kubernetes clusters.
So what? How does that work?
Well, the thing is, this gives you, my developer friend, a pre-configured OTel collector, which follows a standard company-wide configuration. And furthermore, it's configured to already send data to our company standard tracing backend, which is Jaeger.
Oh, that's actually a super amazing feature. This is actually going to prevent all those late night debugging and hair pulling sessions. I love it. Thanks for finding that.
No problem.
Well, I know you mentioned Cradix earlier. What is Cradix? It sounds like some type of crunchy chocolate bar or a space company.
Very funny. Well, Cradix is a framework for building platforms, and it's open source, and their developers are active in the open source communities like CNCF and in the platform engineering communities. We can leverage it to build custom platforms tailored to our organizations. Now, behind the scenes, Cradix provides Kubernetes native API as a service. So basically, software capabilities are encapsulated using a Kubernetes YAML file called a promise.
What's promise? Like you promise to buy me lunch or buy me chocolate?
Well, maybe a honey babka if I get this demo to work. After all, I did put it together magically when you weren't watching. But seriously, a promise defines what to install on a Kubernetes cluster, how it's going to be configured and deployed, and then exposes it as an API so that it can be easily consumed by you developers. So basically, we're making a set of capabilities available to you with more or less the click of a button-ish. So when you install Cradix Promise, it makes the Kubernetes resources encapsulated by the promise available for installation on one or more worker clusters. So in this demo, we will show how developers can use Cradix to install an OTel operator promise. And the idea is a developer can then request the resources encapsulated by this promise, which includes the installation of a test app that sends telemetry data to an OTel collector that is already pre-configured to send traces to Jaeger. Does that sound cool or what?
You do have me quite intrigued. It definitely sounds like it would solve a lot of my problems.
All right, let's get to it then. So, for starters, we are using one of my favorite tools, K9s, to display and manage our Kubernetes clusters. And we have spun up two clusters. First, we have the platform cluster, known as the control cluster, which has the Cradix platform components installed. And this cluster is owned by the platform team and will be used by will be used to deploy services required by developers to the worker cluster. And then we have the worker cluster. And this cluster, which is also owned by the platform team, is where developers like you will be running their applications. So this is where services required by developers will be deployed. So with Cradix installed on our platform worker clusters, we install Promise, we'll do using these three lovely commands that you see here.
Wait, what do these do? Kubectl create something promises? What is all of this?
Don't panic, my dear dev friend. We will dig in and see them in action. So first, we need to install the cert manager because it is a prerequisite for installing the OTel operator. Now, since we're installing the operator as a promise, we need to install cert manager as a promise. And luckily, we can install the cert manager promise from the Cradix marketplace. Very convenient for us. Now, promises are installed on the platform cluster. And the resources themselves, i.e. the cert manager and the OTel operator, are installed in the worker cluster. And then the next thing that we do is install the OTel operator promise. And we can see that both the cert manager and the operator were installed when we see the respective namespaces created in the worker cluster, which we'll see right now. We'll do a list of the namespace, or we'll, check the promises in our worker cluster, and you can see those two promises exist in our worker cluster.
That's great. So, as a developer, how is it that I get what I want now?
Well, you will use this lovely little bit of YAML. It's so cute and compact. All you need to do is run this teeny little bit of YAML in Kubernetes.
Okay, I get it. You platform people are in love with your YAML, but what does this even mean?
Well, this YAML is basically saying, let's request the resources that are available from this promise, i.e. it's going to install an OTel collector and configure it to send traces to Jaeger. And it also installs a simple Go app, so you can go and test the setup to make sure it works, because we all love to make sure that things work, right? And I did that as a little bonus for you because I am super nice. You can see here that we have installed Jaeger and the OTel collector in our worker cluster. So yay!
Yay, this sounds great and all, and I trust you, but as a developer, I gotta see it and try it for myself. How is it that we can make sure that this is actually working?
That's a fair question, and I've got a few little Kubernetes commands to test out this whole setup, so we can dig in right now. So first off, we are going to be tailing the OTel collector standard out, and as you can see, it's up and running because we see all this text on the screen. Always a good sign. It's not screaming errors at us. The next thing what we're going to do is set up a couple of port forwards, one for Jaeger and one for a little test app, so we can access them both via HTTP. So we'll give that a sec. And then we are going to access Jaeger, make sure those port forwards actually work, which they do. And finally, we are going to run our little test app. We're going to run curl against an endpoint in the test app. And as you can see, it returned a value saying that Catherine Janeway signed up. And I'm sorry, I'm a total Star Trek nerd. Couldn't resist throwing that bit into my code. Now, at the same time, you'll see that our collector logs have started spitting some stuff, which is good. It's sending stuff to the collector, and we go back to Jaeger and check out our trace, which exists, and we see that our registrant is Catherine Janeway. Ta-da!
Well, that was really neat. I guess you didn't break your promise, but you did mention you were gonna get me a honey babka. Can you ship that to me now?
Not quite. We're not done just yet because we're going to nukeify this sucker.
But why do you need to show me that? How is this relevant?
Well, look at it this way. If, as a platform engineer, you want to remove outdated or no longer so that you as the developer don't end up using something that's no longer compliant within the company or up to date, I want to make sure that once we remove the capabilities, we do a full cleanup on both the platform and worker cluster. So you don't get any impressions of like, oh, I can still use this because it's still around. So first, we are going to delete our cert manager promise, which, as you can see, when we delete it, the promise resource is deleted from our control cluster. And then next, we are going to delete our hotel operator promise. And again, give it a bit, it'll get deleted from our control cluster. But take note also that when you delete a promise from the control cluster, Cradix does a nice little cleanup on any associated worker clusters so that any namespaces and other resources associated with the cert manager and the hotel operator are being deleted in the worker cluster as well.
Oh, cool. Okay, that was pretty neat. But seriously though, when does my honey babka get here?
Okay, fine. How about I Uber Eats it to you?
Yay. Well, with this, we can see the tools are here to help us. It doesn't matter if we're part of the developer or the platform team, and we can see that taking we can see that taking advantage of self-service tooling can bring a more pleasurable and reliable experience for all of those involved. And let's be honest, the less Jira tickets anyone in this company has, the better.
Absolutely. And with that, and scene.
Scene.
So as we wrap up, I do want to give a huge shout out to Dolly for creating the fun llama images used throughout this presentation, because Anna and I, turns out, are wonderful prompt engineers, but we do not have any artistry in us, like none of that. So all hail to our evil AI overlords for helping to create these fun llama images.
We wanted to make sure to leave you with some resources. So if you actually wanted to take the demo environment that we just showed you today and take it up for a spin, Andriana has written it up in a blog post that you can find here. You can also find Andriana and I's SRE wish list and a little bit of our thought leadership about where we want to see this field continue growing to. And you can take a look and read more about OpenTelemetry or Cradix, or read a little bit about what the CNCF is thinking about platform engineering as a whole.
And before we wrap up, we got to give you a couple little shameless plugs. I invite y'all to follow my new podcast, Geeking Out, which I'm doing with my 15-year-old daughter, who helps to edit it and rejects all technology. So she's not a techie. She's an artist. Probably could have drawn the llama pictures. And definitely check out the podcast that Anna and I had done previously together, called On Call Me Maybe. Both podcasts offer fun conversations on this and other great tech topics. And be sure to connect with us on all the socials, because we'd love to continue this conversation, or hit us up for all things observability, reliability, SRE, or whatever else tickles your fancy. Until next time.
Peace, love, and code.
Love, and code.
Excellent. Well, thank you so much for that. That very fun talk. It was very nicely scripted, well executed. Also, shout out to Hachyderm. That's my Mastodon instance as well. So best.
Woo!
Definitely gonna follow you afterwards. Also, obrigado por compartilhar conosco hoje. And my Spanish is rustier, but gracias por compartir con nosotros. So thank you so much. We have some questions.
Awesome.
Now, it was a very complete talk. It was a very complete talk. And as a result, some people are kind of like, well, how do I ask questions when it feels compartmentalized from start to finish? But there were some very good ones. So I'm actually going to start us off with the most upvoted talk, which, like the previously most upvoted question, was mine. So I'm going to ask it, which is on demand makes sense, right? It's on demand. Repeatable makes sense. It's repeatable. But what about reliable? How are you defining that, or how should we be defining that? And then how is that measured?
I'm happy to take a look at this one. A lot of my focus over the last few years has been reliability. And some of the stuff that we have to think about with reliability comes with redundancy. So making sure that the way that our instances are kind of being set up are that way. So maybe in this type of example that we saw today, you're not going to necessarily see that the instance is coming up with like, oh, auto scaling policies are what you get to see out of the box, like in a Terraform example. But in an example like this, we're actually making sure that the operator is sending things properly to the proper backends. So for some of the other promises that you build, you're actually going to be making sure that you're baking in that reliability into that YAML file that we went through. And every single like promise that you build has different considerations. But we try to make sure to package it in a way that we still talk about observability. Like, hey, as you build on this, make sure that there's observability so you can maintain context into your system, and that is closer to the reliability that that organization is trying to define. And then Adriana and I talk a lot about like setting up service level objectives. I've done a lot of chaos engineering and like disaster recovery talks. That's like make sure that you're going above this type of platform engineering conversation and doing like hands-on practice.
Oh, that makes sense. But if just to dig in a little bit here, what would be like a concrete example of something that can be measured, where we can go, this is more reliable than it was, or we are hitting reliability targets? I'm leading the question a little bit here.
That's
I
where I
can
was
tackle
saying
that
with
one.
this. Oh, yeah.
Oh, yeah. I was going to say, I think like when we look at reliability as like, is the system doing what we expect it to do? I would say that's really what you aim for, right? If your users aren't expecting a certain behavior from the system, and it's doing the thing that they're not expecting, that's when you run into the reliability issues. Anna, if you want to add on to that.
Well, that's what I was saying with the service level objectives. So that we're right now, we started setting up this environment with open telemetry as the first promise, because by getting a chance to put observability as the first promise, we're setting that guardrail that I talked about. That's like, we're going to bake in the quote unquote best practices that our organization is going to have. So we're already going to have every development environment that this team is going to get with observability set up. And then let's say that we had an open source tool for chaos engineering set up. We make sure that that has been set up with security audits. And we can also make sure that any other tooling that needs to get made a promise can also have those considerations. But because a tool like Cradix is not doing the infrastructure disaster recovery, it's like not that type of metrics that we kind of get to see.
All right, fair enough. Thank you for that. We're going to switch gears here for a second. Sarah has got a question about Crossplane. So I'm going to throw it at you. So Sarah mentions that they started to use Crossplane for infrastructure provisioning. Certainly not the only ones. It's a popular project. What possible common, hopefully, but potentially uncommon pitfalls might they face? How do they inject Crossplane into existing infra? Basically looking for, like, okay, we started using Crossplane. What should we be looking out for?
I think the interesting thing about using Crossplane is because it's a Kubernetes native tool and you use it to like provision infra, it means that you need to have a Kubernetes cluster in place in order to install Crossplane to then provision your infra, right? So it's kind of this like weird little circular thing going on. And I think one of the ways, and I played around with Crossplane a couple of years ago myself, and it's a cool little tool. And I think one of the ways to offset that, I think Upbound Cloud has like a managed Crossplane instance. So you basically don't need to have a Kubernetes cluster installed. You just have, you use this managed Crossplane and point it to whatever cloud it is that you're using and have it provision the resources for you. I quite liked it because I remember when playing around with it, I think it it basically got mad if you tried to like manually make changes to your resources, and it's like, no, 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 this is not the state that it's supposed to be in. This is the state that it's supposed to be in. So then it tried to rectify the state, which I think is a little bit different from Terraform, where it's not, at least last time I messed around with Terraform, and please correct me if I'm wrong on that, but I remember like Crossplane was like actively, checking the state to make sure that no, you're not you're not going to violate this by trying to manually make changes to your resources. So I
I'm
guess
gonna
one of
add
the
on
pitfalls, or
just
maybe it's not a pitfall. Oh, I'm sorry. I was just going to say, like, one of the pitfalls, maybe not a pitfall in that regard, is it kind of protects engineers from themselves, so they don't go around and manually make changes. But sorry, go ahead.
I was just going to add, I also haven't touched Crossplane in a bit, but it's also on our to-do list to do for updating this talk in a few months. And one of the things that I kind of still continue preaching around the entire Kubernetes space, and specifically just running your entire workload on cloud native, is like, this technology is still fairly new. That means that the staff that's running these systems, like, we only have a certain extent of time that we have of knowledge of the systems. So I proactively tell folks to make sure to set time aside to do game days, to do chaos engineering, disaster recovery, load testing, failover testing, however your organization is calling it. Make sure to run these drills so that you actually know, like, am I ready for this launch that we're having, this high traffic event? Because you might notice that, like, the team doesn't have that mental model of what's actually going to happen to the system and what type of logs they need to go through, where they actually, what tooling they actually need, where the run bugs are, and things like that. So just something that would kind of, I would call under my pitfalls.
Oh, fair enough. So speaking a little bit about chaos engineering, or comes by many terms, sort of the idea of doing this testing, right? Uh, who should be doing that? Is it putting together little squads? Is it a dedicated team? Is it something else? Who actually owns testing and verifying that these things work or don't?
I mean, this question has very much depended on every single organization. I personally like seeing it as leadership brings it in. So a VP of engineering with a product manager is bringing it into an organization and spearheading the efforts. And then you kind of do start coming together and making organized chaos happen in a way. So say we're going to start tackling the services that have been kind of like having the most incidents but have done enough resiliency work to overcome them. Like, now let's make sure that we have done that work, that in case similar issues happen to our system, we are able to withstand them. Or some other teams actually just look at it of like, let's look at the most critical systems and start chugging along them, but with really small experiments at a time. So definitely would say that it's kind of like a, make sure that there's a someone that owns the chaos engineering project in your company, so that they're actually able to lead best practices and be able to keep data on what is working and what's not working.
That makes sense. So definitely, as you said, sort of a leadership dependent initiative there, something that's going to be a little bit more difficult to do from the bottom up. Of course, that makes sense because you're going to be touching potentially a lot of different teams, a lot of different functions. That stands to reason. Speaking of teams, we have a question from Yuri, and it's a. I mean, if you are playing the DevOps Days bingo game, you're going to get another card here. How do you address the risk of a platform team just being a rebranded ops team? Any advice on
Ooh.
that?
Um, that's a really good question, and I would say one of the things that would differentiate a platform team from an ops team is that they are applying DevOps principles into their work. So basically codifying all the things. I would say that's the main differentiator. Anna, do you have any additional thoughts?
I think for me, it would be a little bit of what I kind of mentioned here is making sure that you're also thinking about that developer experience. I think as an ops team, you're very much just thinking of like, all right, this is the infrastructure that I'm taking care of. I have contact with security, but like everything else hasn't really mattered. Maybe there's actually no good connection there. So I think those are kind of like red flags in a say when you're like, oh, all of a sudden my manager came and I used to be a DevOps engineer and we're platform engineering, but things didn't change. You're just kind of like, oh, you just threw marketing at me and nothing's going to change. And that's when you kind of have to start being like, okay, no, but what is it that we're supposed to do in platform engineering? And it's really about making like things better, keeping developer experience in mind, keeping reliability in mind, consistency. And when all of a sudden you look around and you're like, oh, wait, no, I just have a lot more headaches, that's when you might want to like write down a list and talk to them or talk to the rest of your team and see what's up with everyone else's thoughts on that.
So is the inverse also true? If you're an ops team and you start to apply DevOps principles and you start to think about developer experience, do you become a platform team? Like, is it bidirectional?
I
I would
guess it
say
could
so.
be.
I mean, I personally believe that ICs can be the ones that create change within the organization. They're the ones that come to DevOps Days Ukraine. They go to like other events like this and they say, hey, this is the knowledge that I'm coming in. This team of four is going to be the one that is going to make these changes. And then you start creating these ripples that all of a sudden people are like, oh, yeah, you're right. My job right now is annoying. How is it that I can make it better?
Fair enough. There are some more questions. Unfortunately, we do not have unlimited time. We always don't have enough time to ask all the questions. But thank you so much for coming and sharing a delightful presentation with us, full of really, really interesting food for thought. There's a lot of, as with all the presentations, so much more we could be going into, and the open spaces are a good spot for that. Hint, hint, everybody, get your ideas into the open space now. So thank you, Adriana and Anna, for taking the time out. And all y'all out there, definitely follow them on the socials. Check out their podcasts. Thank you again to both of you.